So we got ions here, pairs of ions, and which ion is larger. Let's look at A. These are two alkaline earth metals. They're group 2 metals. That means they have two valence electrons, one right there and one right there. Which one of them is going to be bigger? Is that what it says? Larger. We already know it's going to be calcium. It's just a bigger atom. They're both losing the same number of electrons. So the answer is going to be calcium. But let's take a look anyway. Magnesium, give myself a little bit more room, is in period 3. Right, so that's, here's n equals 1, n equals 2, n equals 3, and calcium's n equals 4. So magnesium's valence electrons are at n equals 3, 3s orbitals. So magnesium has got 1, 2, they're all full of electrons, those first two energy levels. There's a third one that has 2 electrons. It's going to lose those 2 electrons, and it's going to lose that entire shell. Do that in a different shade of color. So that's gone now, and so what you end up with is a cation that's much smaller. So there's a first energy level, there's a second one, and those are even pulled in closer to the nucleus because there's more, there's less to share with other electrons. All right, so that's your magnesium 2 plus cation, much smaller. That's not even what the question is asking us to do, but calcium. Valence electrons are in the 4s orbital, so n equals 4. Same kind of similar thing here. It's got 2 valence electrons, it's going to lose both of them, and then we're going to get, this is going to no longer exist. All right, 1, 2, 3, and that's going to be your calcium 2 positive cation. Now, in any case, this is going to be the larger one because it just has more energy levels. So, answer is calcium. Now let's take a look at the next one. We have chloride and phosphide anions. So nonmetals are over here to the right side. They generally gain electrons, which is why you notice a negative sign for those ions. So calcium there, chlorine over there and phosphorus. So chlorine is going to, well, they're both in the same period, so this one's going to be a little bit less obvious. All right, so phosphorus, right, so they're both in the same period. They're in period 3, so n equals 3. Their valence electrons, their outermost energy level is going to be n equals 3. So phosphorus, 15 electrons are going to be 2 in the first one, 8 in the second one. That's going to have 5 valence electrons. Right over here, right? Let's just draw them. There's your 3s, and then there's your, whoops, draw too many. All right, there's your 500. There's your 3p sublevel. All right, so it can gain 3 more, which is what it's going to do to become 3 negative. So these electrons, 1, boom, 2, boom, and then 3. 3 electrons is gaining, and now it's going to balloon up. Right, so that phosphide anion is going to be much bigger than its parent neutral atom because we just added 3 electrons. Right, and now all those 15 that were there before are going to have to share the 15 protons with 3 more electrons. Electrons repel each other, so it's just going to balloon up. It's just larger. Now, let's go to, what was the other one? Chlorine, I think it was. All right, so chlorine's got 17 electrons. A different shade. All right, so chlorine's still 3. Give myself a little more room. So chlorine also has 3, not showing all those dots in their core electrons. All right, chlorine's got 7 valence electrons. Okay, so here's your 3s, and then here's your 3p for chlorine. All right, so it's got one more, it's got an opening here for 1 more electron, so that's why chlorine generally tends to gain 1 electron. So when it gains that 1 electron, again, it's going to balloon up because because now the 17 protons that are in there are going to have to be shared with one more electron that came in. So why don't you think about this? All right, which of these scenarios would be the bigger ballooning up? The one, all right, so each of these electrons are sharing 17 protons, and these are sharing 15 protons. All right, but they both have the same number of electrons. All right, which one? So the answer is going to be the phosphorus. You know, they both have 18 electrons, but those 18 have to share 15 protons. And this one's almost a 1-to-1 ratio, so this one's like more repulsion going on because these electrons, they want to get away from each other. So they're just like more spread out, so they have to get bigger in order to do that. I hope that makes sense. So the answer is the phosphide ion is going to be bigger, right over here. All right, let's go on to green here. Copper. These are metals. Copper is a metal. You know that. The only difference is the copper 1 plus has lost 1 electron, and the 2 plus has lost 2 electrons. Remember, can't gain or lose protons. So how do you get a positive charge? You must have lost a negative particle, which are electrons. All right, so you got copper. Let's say that's got right there. This is going to have, oh man, this is going to be, I'm not going to draw the electron configuration because this is an exception. Let's just do a generic drawing here. So there's the neutral copper, right? And it's going to lose 1 electron. Well, if it loses 1 electron, it's going to have 28 remaining. So those 28 electrons have more of the protons to whatever's remaining, the 28 of them, right? So there are 29 protons in copper. That's what makes it copper. But 1 goes home. And the rest of the 28 are like, yay, more for ourselves. So they're getting closer to that action. They're getting closer to that proton action, the nuclear charge. Okay, well, the second scenario here, you got copper again with 29. I'm going to try to, I don't know what I'm going to do. So now, got the same John. All right, now here we are losing 2 electrons are going home, right? 2 of them. Well, we got 27 left. What do you think those 27 are feeling? They're feeling even happier, right? So that they're going to get even closer to the nuclear charge, which is just represented by that plus sign, right? So that copper 2 plus ion, this is copper 2 plus, is going to be smaller than the copper 1 plus cation because there's 27. They're going to be even closer. 27 repelling each other is going to be less repulsion than 28 repelling each other, and they also get more of the nuclear charge to themselves. Right, so copper 1 plus is going to be the larger ion, and the 2 plus you can say is the happier one, or at least the electrons are. Come on, where's my, am I even recording? What is going on here? Where's my stuff?